Hoi zusammen. Hello everyone. My name is Michael Ries. I'm a Principal Program Manager in the Azure Data team at Microsoft. And I'm here today to talk to you about how you can use .NET to do your big data processing with Apache Spark. So let's dive right into it. In the presentation, I will start out with a short explanation of what Apache Spark is. Then I will dive into why we actually want to add .NET support to Apache Spark, given that it's very popular to be used with Python or Scala. Then we talk about what .NET for Apache Spark is. We'll do some demos. We'll go a little bit more into details of some of the internals, including how it is going to perform. And we also talk about where it is available and how you can use it with some of the familiar Spark engines and services out there. And then it's my pleasure to have a special announcement in this presentation towards the end before I wrap up with a call to action. So what is Apache Spark? Apache Spark is an open source offering that provides you a big data processing platform. So you can do analytics on big data and also use machine learning on the data. It improves efficiency compared to, for example, Hive by providing you with a more general computation graph beyond MapReduce. And it does provide you with a lot of in-memory computing primitives, so you don't have to constantly read and write from the file system. It also provides you the ability to scale out your user code and write in the language of your choice. It has rich language bindings and APIs for Java, Scala, Python, R, Spark SQL, and many other languages. It provides you with the ability to do batch processing, but also gives you streaming and interactive shell experiences. The interactive shell is normally known as a notebook. Apache Spark is available on Azure in Azure Synapse, Azure HD Insight, Azure Databricks, and you can roll your own using the infrastructure as a service offerings and Kubernetes clusters. So why do we now add .NET for Apache Spark? In a recently conducted survey of over 1,000 developers that we did in the .NET team, more than 70% expressed an interest in Apache Spark. The main reasons that they mentioned for being interested is that they want to do big data processing, they want to tap into the code libraries, the support, the ability to hire people that understand Spark. But if they look at the current situation, there is no path to use their .NET expertise. And that's because there is really no good .NET support for Spark at the moment out there. So based on that, we decided that in order to be enabling you to run your business code that you have written in .NET and avoid having to go and translate it into Python, Scala, or Java, we are now giving you access to Apache Spark through .NET APIs. Now, the goal of that offering is not to convert existing Scala, Python, and Java developers. Obviously, if they want to, we have nothing against it. But the main goal is to provide .NET developers a first-class experience when they work with Apache Spark. Furthermore, we are developing it in the open. So it's an open source project as part of the .NET Foundation. You have the links here on the slides. We frequently release updates about every 6 to 8 weeks. The current release that we have out there is release v0.12.1. And it integrates with .NET Interactive, another .NET Foundation project, and Interact Jupyter Notebooks as well. Now, in order to be able to bring it into Spark, we did launch 2 project improvement proposals. They have not been accepted yet, so people are waiting until there is more adoption out there before it can be moved into the main Apache trunk. But we have prepared for that with these project proposals. So if you're interested in seeing it as part of the core Apache Spark distribution, please go and upload those project proposals. Furthermore, while we have been developing it in the open, we contributed a lot of foundational extensions and improvements to different open source projects. So you see here a list of many of those Apache Jira's that we contributed to, for example, Apache Spark Core, Apache Aero, and even Purolite, which is the Pickling library that is being used per default to do interop between Python and Java and .NET, and is being used in the context of Apache Spark. But as you notice, you see there Apache Aero, so we are also giving you an Apache Aero option for that interop, and we'll talk about that later during the presentation. The journey so far has been great. We have over 1,500 stars of the project currently, over 200 forks. We see about 1,500 to over 2,000 unique GitHub visitors per week to the GitHub site. We have about 8,000 GitHub views per week, page views. That's both code and documentation. We have so far closed over 260 issues that the community has opened against the project, often asking questions or requesting features that we then added. And as part of those changes that we've done, we have so far merged 246 PRs at the time I took the snapshot earlier today. In addition, we have 39 GitHub contributors that ranges from somebody in the community to provide some updates to documentation, to somebody in the community actually providing code contribution, such as, for example, we have one of our community members, Ed, who is contributing ML.NET bindings, to our own team members that are contributing obviously the core of the coding work and do all the reviews of these PRs. Finally, we are also offering the package through NuGet so that you can integrate it into your own .NET solutions and can build your .NET Spark applications. So far, we have 127,000 NuGet downloads registered through NuGet. Now that's interesting in one way because it doesn't necessarily mean that we have 127,000 Visual Studio projects for that. Every notebook interaction, every notebook that you create, for example, in Azure Synapse is going to, for example, do a NuGet download to get the right version of the package installed. So that way, that of course kind of increases the numbers a little bit there, but 127,000 Ks is not bad and nothing to sneeze at. Furthermore, just to show you a little bit more of the interaction with the community, our community has been very active, engaged, and happy about what we have been offering. We even have people writing blog posts, doing videos, providing Docker images. For example, Indy here has done a really great job in providing a .NET for Spark Docker image if you want to use it in a Docker context. We also have people doing blog posts on how to use it with Jupyter notebooks, etc. And as I mentioned, we have a lot of these people also contributing to the project itself. So definitely, if you're interested in contributing, etc., go to the GitHub site, sign up, and start helping out. That's always appreciated. We already have a few customers, mainly Microsoft internal at this point, that have been going into production with it. So, for example, the Microsoft Search Assistant Intelligence team has been building ML deep models on the data that they have in Azure Data Lake Storage and have been using .NET for Spark because a lot of their business logic, like the featureizer, tokenizer, etc., are all written in .NET. And so having to translate that was too much of an effort. So they basically were very happy when we came with .NET for Spark and approached them. and now they are using those libraries to run those libraries at scale over their data. And the scale is about 50 terabytes of data. They are very happy with the experience so far. They find it very stable and like that there is a vibrant community out there, not just for the Spark side, but also for .NET for Spark. And they are looking forward to using it in further projects as well. So now what does .NET really provide in terms of Spark support? The main aspects that we provide is that you can write your Spark applications using .NET against Spark data frames. So not RDDs, not datasets, but Spark data frames, which is kind of the 80% use case that we see when people do Spark processing. Furthermore, besides being able to write your Spark applications in .NET, you can also write .NET Spark user-defined functions that you then can use and use in the context of Spark to apply them at scale to your data. It works with Spark version 2.3 and 2.4 and includes over 300 Spark SQL functions grouped, mapped, and has support for the open source Delta Lake version 0.6. Furthermore, it's fully based on the .NET Standard 2.0 standard, which means it works with .NET Framework version 4.6.12 and higher, and .NET Core version 2.1 and version 3.1, and includes C-Sharp and F-Sharp support. Now, please note that we normally recommend that you use .NET Core because that's the most portable experience, and unless you're running your own Spark cluster on a Windows environment, it's normally that you're running Spark in a Linux environment, which also means that you should be targeting .NET Core. It gives you batch and streaming APIs and all the Spark supported data sources. So if you, for example, have a data source that you are reading that is Parquet files, ORC files, have a special JSON connector that can read, Java connector that can read any of your data formats. You can use those and address them also from the .NET side easily. Furthermore, as I already mentioned, we have added access to ML.NET from the .NET side. We have interactive notebook integration with the C-Sharp REPL experience that is provided by .NET Interactive. And we are also doing a lot of work around performance and speed and productivity so that we get faster interop. Our goal is to be as fast or faster than PySpark. And we also added support for hardware vectorization, assuming you can take advantage of that. Examples for all of this, plus documentation, obviously, is on our GitHub site. So we recommend you to go there and dive in further. So now let's talk a little bit more about how to actually program in Spark with .NET. Let's start out with the data frame abstraction. So data frames is an abstraction that basically gives me the ability to take arbitrary input data, CSV data, JSON data, relational data, Parquet, binary data, MySQL data, ORC data, all kinds of different data formats and data sources, and give me a relational data frame abstraction over it, which means it looks basically like a table with columns and rows. Now, the data frame itself is designed in a way that you don't really have to worry about scale. So don't worry about having enough memory to have all the data from your Parquet file fitting into memory in the data frame, etc. The whole point is that Spark gives you a scale-out architecture so that you can scale out over large amounts of data. So if the data frame contains a few billion rows, if you have enough cluster size, even if you don't necessarily need everything in memory, you're fine. It will work. Now, we'll talk a little bit further later why that is the case. And then obviously you can have your user program against the data frame abstraction using domain-specific language, which is very similar to LINQ. And we'll show you some examples now. So if you do .NET for Apache Spark programming, you start out with creating a session. This is done using the standard statements that you're probably familiar with if you have done Spark before using Python or using Scala. You get a Spark context there. And then with the Spark context, you can read data from somewhere and basically create a data frame. Then in the next step, for example, you could define a user-defined function. In this case, I define a user-defined function called concat by taking the lambda expression that takes an age and a name and concatenates the name and the age together. Both of them are string data types. And then, one is an int and one is a string, and then it returns a string as a result. Now, this user-defined function can then be used inside my normal Spark expression. Now here you see an example of these DSL operations, domain-specific language operations, on the data frame object that normally take a data frame, apply their transformation, and then produce another data frame. Now if you look at this, you see there are two types of methods on the data frame object. One is the transformation, which is doing what I just described. And then you have another set of data frame expressions that are called actions. Now the interesting part is that each of the transformation is just transforming the data frame from one data frame into another. It doesn't actually execute the statement. What it does is it captures the execution tree of the operations, how they are being composed as you're writing those expressions. So it's very similar to LINQ on iQueryable objects. And actually, Spark in its history has been very much influenced by the work that we have done on LINQ and iQueryable and also our own internal big data processing platform. So if you're looking at this now, then obviously at some point you need to trigger an execution. And the execution is triggered by some of these actions. So what actions do we have? We have, for example, show here. There is collect that I will show you in the demo, and a few others that basically then trigger the execution of that execution tree by submitting it to the Spark engine and get it executed. So now if you look at the actual Spark language between how you would write a certain query in Scala versus .NET, let's look at an example of the TPCH benchmark query 2. So TPCH is a benchmarking and often used in relational benchmarking, and we also have been using it to benchmark our own .NET experience here. And so you see here on the one side a Scala expression that takes some joins between nation suppliers, part suppliers, etc., and does apply some filters. Then it applies some more filters and some more joins. Does some group by aggregation, some more joins and filters, and some sorting, some limit, and then it finally shows the result. So this is now obviously Scala code with Spark. Now here's the same code written in C# with .NET for Apache Spark. So if you squint at it, it looks very similar. It's very dangerously copy-paste friendly, which is by design because we want to make it easy for you if you are searching online in Stack Overflow or through Bing or Google for a solution that you are looking for like how do I do a join in Spark, then assuming that you're probably not finding necessarily a C# solution but a Python or Scala solution, we want to make it very easy for you then to just adjust it to the C# experience. Now, there are, of course, a lot of small differences between Scala and C#. So, for example, you see C# is using a double equal for comparison, which is, for me, as an old SQL guy, already weird. And Scala makes it even weirder by turning it into 3 equal signs. I wonder what the other two are. But also you see, for example, val versus var and a few other like language specifics. But then you also notice that Scala has this short form for referring to column names. We are currently in C# only providing you with the column function that Scala also has. And then obviously we are following the capitalization that C# has. And so we start with uppercase camel casing, while Scala has lowercase camel casing for its keywords. So now let's go and take a look at some demos. I've talked enough so far. So we start out with the tweet, some tweet files that I have local on my local machine here. I installed previously an Apache Spark installation locally. So I will be using now Visual Studio and .NET for Spark to start doing some processing. Primarily, I will do some extraction from that CSV file, do some transformation, and then I will show the result. Then I will be executing this locally on my machine. I will show you how I'm doing that. And then I will show the result on my console. So let's switch over to my Visual Studio. So here I have my Visual Studio. I already have created a project here. The main important part here about the project is that this is a standard C# console project. It has been added the NuGet reference to the Microsoft Spark .NET NuGet package. You see here I'm a little bit behind. I'm still using 0.6 here. I should probably upgrade to 0.12.1. And then I have my program here. Now the program is a very short one. You see the class starts. I specify the input file that I want to process. I go and then create my Spark context here. So this is very similar to what I would normally do. Then I have my Spark read schema format CSV load input file. So as you can see, the input file contains 4 columns: date string, time string, author string, and tweet. So very simple input file. And then I do simple group by author, count, order by descending. And then I show, meaning execute, the data frame against the Spark cluster locally. So as a next step, after writing the code, I go and build it, or rebuild it in this case. Now, this will be writing the file into a target directory here. So you see down here, I use this path here, and will copy that over into my console so that I can do the submission to my Spark environment. So let's do that. Let's see, where is my... So you see here, I'm already inside my directory here. And now I'm using the standard Spark submit command to submit my .NET Spark application. Now, in order to do that, I actually have to use the Apache Spark deploy .NET runner class as the actual Java, JVM, Scala application that I'm running through Spark Submit. This .NET runner is now using the interop hooks that we have in Spark to execute my kind of local execution. Now this class obviously comes out of the Microsoft Spark jar file that we have provided you as part of the NuGet package. And it will be using .NET ignite demo.dll, which is the code that I created earlier, and execute that. Now, if I hit execute, it will take a little bit of a while to spin up my local Spark cluster and connect to it, and then run the query. So while that's doing that, let me quickly go back to my presentation and summarize here on how to submit a Spark application. So you have Spark Submit in Scala, which basically gives you the class that you want to use out of the user jar, which is the main class. You say where you actually want to like run the master. So in this case, it's local. And then you provide the jar file and optional arguments to the application. Similarly, for .NET, you would do the same thing, except for that the main jar file are the jar files and the class that we provide you with. But then you basically give the path to your application execution and then the argument to that application. So let's go back and take a look at what it's actually doing. So you can see it's executing now. And now you see the result here. Let me scroll back so you can see that. Because the shutdown here is giving me some error messages, which is normal. So you see here now my local file and basically the author and count that I have created inside. So pretty straightforward. Let's go back to the presentation now and take a look at how to actually do local debugging. So one thing, of course, is unless you're very well versed in .NET and Apache Spark, you will probably need some local debugging. And so we made it very easy for you to basically run your .NET for Spark application from within your favorite debugger. I'm using Visual Studio here to actually be able to set breakpoints and look at the code both in the context of your master program as well as in the context of your user-defined function. There is even a way to go and debug the Java and Scala code that is running. Although I'm not going to go into that, we have a short documentation on our GitHub site on how to do that. So what we are doing in this demo is we do the same thing as before. We take that tweet file, we take the same code. But this time, before I actually run it, I will start my Spark submission as a debug session. So in this case, I'm now basically starting the Spark job. And I give an argument to my .NET runner that says debug. Now the debug then will be starting to wait for actually seeing an actual program being run and submitted. And once it does that, it basically will integrate into the debugging experience that we have in Visual Studio. And I can do some steps through debugging. So let me show you this. I have another command prompt here using this statement that you have seen earlier that says debug at the end. Taking a few seconds to load again. And so now you see it says .NET backend running debug mode. Press enter to exit. Obviously we don't want to exit. Instead I go now in here into my same code session that I had before. And let's set a breakpoint maybe after I do the Spark session, but before I do the tweet here. So now I start the program. And so now you see that it actually connected and it's now running this in a separate file here, separate window, sorry. And now you see here we already stopped. So let me switch back here. And now I can like look at this. So right now the tweets is null. If I now do this next step. So now we have reached the breakpoint. Let's see how we step through this. So you see now it's executing again. And it's, if I look now at tweets, you will notice it's a data frame object. Now the group tweets hasn't been executed yet. Unfortunately, I can't like go inside. It has non-public members here. So you see down here some JVM object reference. So there are some JVM objects here. Unfortunately, I can't dive in deeper. And now let's do F10 again to get the next statement. And you see it's done fairly quickly. I'm not actually executing anything here. I did execute a little bit up here because the spark.read to create a data frame actually looks at some information and does run some statement in the Spark main process. And now the .show is the action that I mentioned. So far, the actual expression that we have up here hasn't been executed yet. So the next statement with continue here will actually now run the query, and it will be doing the execution. So to show you that it's running the query, going over here. So you see now how this is running again like earlier. And now you notice it has stopped, and you see here is the result. And same result as before, fortunately, so we're good. And now let's return back to the presentation. So you now have seen how to do local debugging of your user code. Now, user-defined functions is a little bit more complicated, but not by much. In addition to writing your application code like the way that we've done, you have to go and set .NET Worker debug to 1, and then run the Spark submit with the debug argument as we had before. Oops. And then you go and set your breakpoint at your business logic and do F5. And then in the choose just-in-time debugger, you have to select your app code CS file to basically find the user-defined code. And that's it. So now we have shown you how to use .NET for Spark on my rather weak local machine. It's much more interesting if you can actually scale your complex data processing out in the cloud. So with my next demo, I'm going to show you how to actually process lots more data using .NET for Apache Spark, doing complex data preparation with it, storing it in Spark tables, and then do some interactive .NET investigations of the data using an interactive .NET for Apache Spark notebook. So in order to be able to do that, I'm now going to my Azure Synapse Analytics cluster or workspace. Here I have the same set of data uploaded. So you can see here we have all the tweet data files again. If I do a preview, oops, trying to download it, sorry about that. You will notice again it has 4 columns here, date, time, who tweeted, and what the tweet was. So now we have 2 ways of processing this. If I go into the development hub here, you will see that I can have notebooks, which are and Spark job definitions. The first thing I want to do is look at Spark job definitions. That's a way for me to run Spark batch jobs. And for that, I have to upload my zip file of a .NET published kind of solution into my cloud storage. So I've put that into my AWS storage account here as Ignite demo zip. And then I have here the ability to have a Spark job where I can specify the language. So and then down here you give the submission detail, like which Spark pool you want to use, how big the execution size is. Since it takes about 2 to 3 minutes to just provision the Spark pool, because I haven't used one right before, let me submit this and talk a little bit more about what you see up here. Let me zoom in so you see a little bit more details here. So what you give here as part of your batch job processing is you give your main definition file. So you give the zip file that I have uploaded. You can also upload it from the UI here. You specify what is the main executable file, which is basically the program name. You can provide command line arguments for your main executable, and you provide additional reference files like additional DLLs that are, or resource files that might not be part of the zip file that you have uploaded, but that are needed as well. Now, and these files, again, all should already be up in your cloud storage. Now, an important aspect here is you will probably notice is that you don't see that .NET runner here, and you don't see the kind of jar file that we specified. And the reason for that is that that's already built in. And we actually give you a specific language option here to for your Spark job definition. So you have not just .NET for Apache Spark, you also have obviously for Scala, Java, you have it for Python, etc. To submit your job here. And by the way, yeah, so if you have, for example, existing libraries that you want to like add to it and you don't want to necessarily put it into the zip file here, you can add it here to your reference files. So as you have seen, the job has now been submitted, and I can now open the Spark monitoring location here to actually see how the job is doing. So let me open that quickly. And so you see here the Synapse kind of visualization of the job. You see it's already running for about 2 minutes. That's primarily the creation of the Spark resources of the Spark cluster based on the Spark pool definition that I submitted it to. If I refresh here, you will see that it's starting to show more once it starts getting more information. So you see now the job has succeeded. It's loading the job graph of what the job actually did. Now in this case, the job is fairly simple. It consists of 2 stages that it executed. You see how much data it has written, how long it actually spent in those 2 stages. This is similar to the information that you see in the Spark history server, which I will open in a minute. And then down here you see the output, both from the driver or from some other environments. So in this case, obviously, we got the result. So I go to standard out here, move that up a little bit. And again, you see that group by aggregation that I've done locally now against the data that I have inside my storage account in the cloud. Now let's go and take a look at the traditional Spark history server. So that's just kind of like the more common experience that you get when you're using Spark. And so you can obviously, if you're used to this UI, you can go in here and navigate in and dive in further, etc. Look at your stages here, etc. So having shown that, that's for doing batch mode processing. Now, the other thing I want to do now is I actually want to show you how to do a little bit more interactive, interesting processing. And in order to be able to do that, I have 2 notebooks here. The first notebook is a data preparation notebook. Obviously, I could also do that as a batch mode, but it's easier for me to demo it, so I show that. And as you can see here, the notebook gives us interactive C#. Now, I'm not going to execute this for the purpose of time because, as you can see down here, the notebook pool, Spark pool that it runs against is currently stopped. It takes about 44 seconds to 2 minutes to start up. So I'm not going to do that right now. But as you can see, the expression that I have here, ABC.split with spaces, is actually just a standard C# expression, nothing special. And what it gives me here is a C# result. Now, in the next cell, I'm creating a user-defined function in .NET called extract items that takes a tweet and basically splits it into words and then gives me back the words that start with a certain prefix. Now, that function I'm using to create 2 user-defined functions called extract mentions and extract topics, which basically take an input column and give me an output column of type IEnumerable string. What it does is it basically takes a tweet and looks for @ signs, which is mentions, and for hash signs, which is topics. I'm now using this to read my data. This time, instead of reading one file, I'm reading all the files inside my tweet folder. I then go and read it, again, CSV data files, and I do some deduplication because I potentially have multiple files containing the same tweet. So down here you see the job execution. Once I hit enter here, it executed in 18 seconds. You see the 2 stages here of the job that got executed as part of this cell. Or actually in this case it's because I did 2 counts here, which is both an action that is actually executing it. It's actually 2 jobs here. And the first one took 7 seconds, the second one took 2 seconds. And you see here the output says that I removed 185 duplicates from my tweets. On the next cell now, I'm going to use my extract mentions and extract topics on the deduplicated tweets to get my mention and topics data frame. Again, when I do a show, it shows me the standard data frame here. You see here's an array of mentions and array of topics. Now I want to create tables I mentioned earlier. So what I do next is I want to pivot the array into 1 row per array item, and let me go back here to refresh it. And 1 row per topics. So in this case, I'm using the explode built-in expression and rename it again to mention, and return this in my data frame. In this case, it's a new data frame called mentions. Again, the show will execute it, so you see the result here. The same for topics. Then I go and run some Spark Sql expressions here to create tables and clean up. So you can see here Spark.sql works from .NET. And now here I'm writing the 2 tables. You will notice I only have about 30,000 rows in one and 18,000 rows in the other. So in order to avoid over-partitioning of my tables, I do a repartition of the data frame into a single partition, so it only writes a single file for the table, and as I save as table. Now this will be making them available in a table. So I can now use, for example, another notebook to just go and read and do some analysis. So again, here I have an existing analysis notebook that I have done with .NET. So I can just use some standard .NET for Spark C-Sharp methods like spark.table, group by author, aggregate, order by descending. So that gives me basically the count of distinct topics per author. Or I can see the count of distinct mentions per author just using Spark SQL as well. And note I can use user-defined functions obviously in both if I need them. I can do daily count of distinct authors and daily count of how often a topic has been tagged, which I do with this .NET for Spark C-Sharp method expression. And I can also do some more interesting questions, like, for example, let me see how high the influence is in terms of mentions and tweets. So what I do here is I take a first data frame that calculates from the mentions the count of distinct tweets of authors that have provided me their tweet files. So I need to provide like just the ones that actually I have files for, not the ones that are mentioned in those files. Then I get the mention counts for all of them, adjusting for some changes in account names. So for example, in this case, you see me use a Spark SQL expression with a common table expression that replaces my old name to my new tweet name. And so I have adjusted mentions here, and then I do a group by mentions down here. And then I calculate the influencer score as the number of mentions divided by the number of tweets. So down here, the result, as you can see, executed in about 7.5 seconds. You see all the authors with their counts. You see the mentions and their counts. And now you see who is the most influential one. So you can see, interestingly or not interestingly enough, people that are tweeting low numbers but get mentioned a lot are obviously more influence, have more influence than people that tweet a lot but even though they get still mentioned a lot, are not getting mentioned as nearly as much in terms of the relationship. And you can see I'm kind of in the middle field here, so I'm not very influential at all. Now we can do some cool visualizations. One thing that the .NET Notebook gives us, so that's not .NET Spark, but I want to show it anyway, is we can go and override the formatting rendering of an object. So in this case, I create a .NET Interactive Formatting Formatter for the data frame object and register this. What this does is it basically takes my data frame result and will now create an HTML table for that using some nice CSS formatting. Now I'm not very good at UI design here, so I'm just using some light gray and black visualization. So now to show that and to show you the last query here, I will use that to visualize my top 5 quarterly topic tweets to kind of see what I have been up to in the last 10 years of working at Microsoft. Now, you can see here, this is a fairly complex Spark Sql expression that I'm using here. And I will show you both the standard.show kind of action, but I will also just show you how I invoke the data frame object here. Now, normally that would just tell me this is a data frame, but because I have now this special formatter, it is now showing me the actual HTML that I created. So you can do a lot of interesting visualization here with a special formatter if you are like very adept at HTML programming. Now, one way of how this is being used is that we have some built-in libraries, such as the Plotly library. And so I'm now using the Plotly library to actually visualize that top 5 tweet topics on a quarterly basis. You will notice here I use quite a bit of link expressions here. Now, obviously, link expressions are not being executed by the Spark cluster. So in order to be able to execute that, I have to go and collect the result of my Spark expression. So that means obviously at this point in time, the data frame gets executed, materialized, and put into memory. So I have to make sure that that data volume is not too big. And then I basically create bar charts and do some layouts. Here's the result of this. So this is the actual Plotly library result. You will notice here I have kind of 3 peaks between 2010 and 2020. The first peak looks like, if you hover over it, I was working on SQL Server beyond relational capabilities, was presenting at SQL Bits here back in 2012. Then I fell silent, didn't tweet. That was because I was working on some internal big data solutions and also preparing for the next product, which was Azure Data Lake and uSQL. You can again see here I tweeted a lot, including at previous SQL Bits. And then I fell a little bit quiet again. And then you see me starting to tweet up again. And now I'm tweeting about Azure Synapse and .NET for Spark. And that will be basically the next kind of adventure that I'm on. And obviously the UI here has a lot of interesting kind of abilities. So I can, for example, go and look for, let's say, data lake here. And it basically kind of allows me to select and deselect objects here so I can do some additional analytics. So this is the demo of actually doing some Twitter analysis in the cloud. So let's go and continue with the presentation. So what is actually happening when you write the .NET Spark code? Well, you have your .NET program that uses data frames or Spark SQL. And both of these are basically translated through the .NET for Apache Spark into the Spark operation tree. So that's basically what the data frame contains. Now that Spark operation tree, once we submit it and actually execute it on the cluster, it has 2 execution paths. If we did not define a user-defined .NET function, then it's just a regular execution path and there is no .NET runtime involved during the execution. So you will get the same speed as if you would have written that with Scala or Python. It's executing the Spark operation tree using Scala Spark. If you have a user-defined function, then you will be using Scala Spark for all the non-user-defined parts, but then it will use interrupt between Spark, JVM, and .NET to actually give you the execution of that user-defined function. Now, as I mentioned earlier, our goal is to be equally as fast or faster than with PySpark, and so we'll take a look at that in a minute when we look at the performance. Now, there are a few aspects to the performance. As I mentioned, the worker-side interrupt is kind of like a really core part that we have to address because we are running code in .NET. So if I have a task with a UDF, then it launches this worker executable, which is our Microsoft.Spark worker. It serializes UDFs and data on the Spark Scala side into the .NET environment, and then we execute the user-defined operations by calling into the .NET library that we provided that contains those user-defined functions. And then eventually we'll have to serialize the result back into Scala. So now the question is, how do we best serialize the data between the JVM and the CLR? There are two options here. One is using Pickling, which is the same approach that Python does, or Apache Aero, which is a column-oriented format, which obviously is better for the standard column-focused processing where you pass one or two columns into UDF and you're not passing rows into UDF. Now, the Pickling is the default that you get, but we do give you the ability to actually run with Apache Aero as well. Now, the way to do that is if you take a standard kind of group by aggregation here, where we do a count character in this context. So this is the code that you would write with Pickling and standard environment. Now, if you want to use Aero, previously you would have to write a fairly complex code there with a lot of record schema, get field index, and data type conversions and all kinds of complex code. We actually improved that by giving you additional abstractions so that you can use an FX data frame in this context to actually use Apache Aero and use this to process your data efficiently. Now let's take a look at the performance here. We did do some performance tests on Azure HD Insight using the Spark language runtime. You see the versions of Spark and .NET that we used when we did do the performance test here. And these are the performance runs when we use the Pickling serialization. The Aero improvements we'll take a look at on the next slide. And again, these are the TPCH data sets and queries so that we are running here. And you will notice that for most of the queries, we are actually more or less the same, regardless of which languages we are using. Like it's within the kind of statistical significance here in most of these cases. Now, the reason why that is because, as I mentioned earlier, if you are not using UDFs, there is no .NET interrupt, and so we are on par with Python and even Scala. Now, on the other hand, we have a few queries here. Specifically, let's focus on query 1 and query 8, where we do have actually done some user-defined functions as part of our implementation of the TPCH benchmark. And you will notice that in query 1 and as well as in query 2, we have a few billion rows that we have to interrupt between JVM and CLR. And we can see here that we are actually 2 times faster than Python using Pickling serialization. So now we go and look at the comparison between Pickling versus Aero Serialization. So here you kind of see for these two queries that we looked at earlier that the Aero processing is actually quite a bit faster. In one case, almost a third faster, because we have better serialization and because of the columnar format that Aero has that is better suited for that type of user-defined function that we are invoking. So Aero is most likely going to give you faster performance if you need to tune your user-defined functions. Now, of course, you can argue we can also use Aero with Python. So is Python going to be faster than us? And the answer to that is actually no. Now, the difference is here much, much smaller. And in some cases, like in Query 8, it's within the statistical noise. But the good news here is one, if you like .NET, you can stick with .NET. You don't have to switch to Python just for performance, for user-defined functions. And you will notice that even in other cases, we are probably faster, especially if we have more complex code that needs to get executed. Obviously, .NET is going to be optimized, compiled, compared to Python, which is an interpretive language. So now let's go and talk a little bit more about where it's available. First, our .NET for Spark library is multi-platform, so you can use it on Windows, Ubuntu, and probably other Linuxes, but we have tested it with Ubuntu, Mac OS, and it's cross-cloud, so you can use it on Azure Synapse, Azure HDI, Spark, Azure and AWS Databricks, and AWS EMR Spark. We even have a user there. In the case of Azure Synapse and HDI, we actually have it installed out of the box, so you have a much more integrated experience. You don't have to deploy the .NET runtime. You don't have to deploy the libraries that we have, etc. While in the AWS case and in Azure Databricks, you actually have to go through a few steps of installation. The installation documentation is on GitHub, and I will also quickly mention it for Azure Databricks, what works. So, as I mentioned earlier, if I go for .NET for Spark in Azure Synapse, do batch submission, I have to do a .NET publish of my application to .NET Core App 3.1 for Ubuntu, which is what we're running the Spark clusters on. Zip up the folder, then upload the zip file to the cloud storage, and then basically submit it using the special submission. Now, in the notebook, again, we already saw the examples using the .NET Interactive C-Sharp experience. Now, if you want to go and import existing NuGet packages, for example, you can actually do that with a magic command, #R. So in this example here, you import the MathNet numerics, and then you can use them inside your other cell. This is a capability of the .NET Interactive experience. Now, if you want to use .NET for Apache Spark in Azure Databricks, it is not available off the box, but you can use it in batch submissions. And we have the documentation here on this link. It works fairly well. We have quite a few customers that are using it that way. Unfortunately, the traditional Databricks notebooks are proprietary and cannot integrate .NET unless Databricks is actually doing the work to integrate it. We can't do that. We don't have access to their code. So my recommendation is if you really want to have .NET for Apache Spark also be usable in Azure Databricks in a similar easy to use experience as we have in Synapse and the Azure HD Insight, I would recommend that you should contact Databricks, Twitter handle is here, and ask them if they could actually consider adding that to their distribution. Now, I've shown you Visual Studio to program. There is also a VS Code extension for Spark.NET. That gives you the ability to submit it for Azure HD Insight classes right now. Azure Databricks and Synapse integration, I think, is planned. Again, if you want to know more and have any requirements there, please let me know. So now I said at the beginning, I have an important announcement to make. The important announcement is that we are going to release .NET for Apache Spark v.1 soon as I do the recording of this presentation, and probably already has occurred by the time the recording is live. So it will give us, as I mentioned earlier, the Apache Spark data frames and structured streaming and Delta Lake. We will be adding Spark 3.0 support as part of V1 release. As I mentioned, it's based on the .NET Standard 2.0. We have the performance optimizations with Apache Aero and hardware vectorization. We have provided you with this first-class integration in Azure Synapse. And if you want to learn more, please go to .NET at Spark. So what is next? while we are looking at what we should do next year, some ideas such as, for example, idiomatic experiences for C# and F#. Is that something you're interested in? Spark connectors in .NET for other kind of offerings. Tooling experiences such as, for example, better integration into Visual Studio so that you can submit it out of Visual Studio and Visual Studio will do the right thing for certain systems like, for example, Databricks or Synapse. And also, obviously, working with other partners once they get interested in providing an out-of-the-box experience. Please go to our GitHub and let us know what is important to you. If you have any provider of Spark distribution like Databricks or Amazon or so, and you want to have them the .NET experience out of box, please contact them and we will happily work with them. So I would like to thank you for your attention. Here is some additional information. Feel free to tweet me at Mike.BigData. Use .NET for Spark as your hashtag. Also feel free to watch my related session on big data and data warehousing together with Azure Synapse Analytics, where I go into way more detail about how Azure Synapse looks like beyond just the .NET experience. And I hope that based on this presentation and based on the code that we have released, you will love Apache Spark together with .NET. Thank you.